Hey guys, today we are going to continue on to our um, introduction into the periodic table. Today we're going to look at the parts of the periodic table. We're going to look at metals, nonmetals, and metalloids. So let's just go in and take a look right now. Our first thing on here that we have is that the periodic trends that we see on the periodic table are a result of the electronic or the electron arrangement. That's very true. How things are arranged there will depend on how something bonds and the reactivity of an element with another element, how it will bond and react with that. Valence electrons. This is a review of our last unit. Those are the electrons in the outermost energy level of Bohr's model. If we take a look at carbon with 6 protons, 6 neutrons, okay, we had 2 electrons in the first energy level, and in the second energy level we had 4 electrons, and in the Lewis dot structure we had 4 dots around it. This is what showed the valence electrons. Those are the electrons in the outermost energy level. That's the valence electrons, those last electrons in this very last outer ring of Bohr's model. Those are the valence electrons. And again, those are the ones that determine the chemical properties. That's why they're so important, is because those are the ones that are going to be involved in bonding and how they react. So those are the ones that are the most important, okay? All elements in a group of the periodic table have similar valence electrons, and hence they all react chemically similar. So if you look at lithium, potassium, sodium, rubidium, cesium, and francium on the very first column of the periodic table, they all have 1 valence electron, and hence they all react similarly because they all have 1 valence electron, okay? And that's what I have here. Lithium and sodium here have similar physical and chemical properties because they have 1 valence electron, because they are in group 1 on the periodic table. And remember, when I talk about group, okay, I am talking about a column on the periodic table, because that is the name that we give columns on the periodic table, is that we don't call them columns, we call them groups or families, okay? Property of elements in different groups are not exactly the same. So example, sodium and calcium, they are in different groups, and hence they are not exactly the same. So they're in different groups, they're in different columns. Again, a group is a column. They are in different groups, they are not the same, okay? All right, metals. Metals on the periodic table are good conductors of electricity. They are on the left side of the periodic table. Here are the 5 properties of metals. Reacts with copper 2 chloride, and that's the chemical formula of copper 2 chloride. You don't have to memorize that, but that just is some information for you. Conducts electricity, has luster, is malleable. Luster, if you're not familiar with that, it's shiny, okay? It's not glittery, it's got a shine to it, okay? Malleable means that it can be bent. If you hit it with a hammer, it bends, okay? And then reacts with acid, particularly hydrochloric acid, which is HCl. It reacts with other acids, but hydrochloric especially, okay? Some particular information, transition elements. Tungsten has the highest melting point of all of the metals on the periodic table. Little extra information for you. Non-metals are poor conductors of electricity, and they are on the right side of the periodic table. And I'm going to go through the periodic table and show you where metals, nonmetals, and metalloids are, okay? We've got metalloids. They have intermediate electrical conductivity, which is why they're so good for electronics, because when you want them to conduct electricity, they will. And when you don't want them to conduct electricity, they won't, okay? Like silicon. Silicon is a metalloid, and we know that is used in computers because it is that metalloid. It's got that intermediate electrical conductivity. They are falling on the staircase, okay? And then, like everything in chemistry, there are always exceptions. No matter what topic we are talking about in chemistry, there is always exceptions. And here they are: hydrogen, aluminum, and astatine. And I will go through that. So let's go through. So that's as far as I'm going to go through the notes, but I want to go through actually on your periodic table and show you where the metals, nonmetals, and metalloids fall on your periodic table. So if you would get out your periodic table right now, I'm going to show you this right now, okay? First thing I'm going to do here is I'm going to show you where the metalloids are, okay? And the metalloids fall directly on the staircase, okay? So we have boron, silicon. Now I know aluminum looks like it should be on the metalloid list, but it is not, okay? It's an exception, so we're not going to color that in, okay? But we're going to color in germanium. We're going to color in arsenic. We're going to color in antimony. We're going to color in tellurium. And we're going to color in polonium. And we're not going to color in astatine. And then we're going to blank out elements 113 to 118. And the reason being is those elements have just been recently discovered. Their properties have not been fully isolated yet. And so we don't exactly know yet 100% as to what their properties are. So those are the metalloids, okay? So now what I'm going to do, okay, is in blue, I'm going to do the nonmetals, okay? And the first nonmetal that I'm going to do is the one big exception to our list, and that is hydrogen. And hydrogen is way off over to the left, okay? So hydrogen is a nonmetal, okay? All of the other nonmetals are off to the right of the staircase. So all these elements here, these are all non-metals. All of these are non-metals. Okay? And then I have a lot of elements that I have not filled in. And I'm going to fill those in as green. And the rest of the periodic table is all metals. And so you can see that the majority of the periodic table here is a metal. Most of the periodic table is metals. So everything here, these two tables, all this middle section, over here underneath the staircase, Okay. And I'll tell you about a little bit about these bottom two rows down here. They're actually pulled out, like you see this gray part that's right here, okay? These bottom two rows are actually pulled out from where those green ones are, okay? And I'll let you in on a little secret, okay? The reason why we pull these bottom two rows out of where that gray stuff is really the only reason is to fit it on an 8.5 by 11 sheet of paper. Seriously, okay? Because otherwise the periodic table would be so wide, it wouldn't fit. And so those bottom two rows have a special properties. We pull them out and now it fits on a piece of paper, okay? But that is a picture of our metals, nonmetals, and metalloids. So right on the staircase. So you will always have that staircase there to alert you as to where that metalloid is. So the staircase is the metalloid. Everything to the left is a metal. Everything to the right is a nonmetal. And there you go. And that is our introduction to the properties of our periodic table. And so the next video will get into what we actually call the individual families on the periodic table, because each individual family has a specific name to it. So we'll get into that in our next video. So go ahead, get some work with filling out metals, nonmetals, and metalloids. Ask questions as you go along. Good luck.